Okay, can you hear me?
Yes.
Thank you. Gianna, are you healing?
We're doing good.
Good, glad to hear it. For those of you that don't know, if you don't mind me sharing that information.
I don't care.
I need your permission to do that. She wiped out on a skateboard, got hurt really badly, emailed me and said, I want to turn in my homework late. And I was like, heck with you, turn it in. So, okay. We are here, February 17th. Quiz due tonight for this module. And the lab pre-lab stuff is due tonight also. Homework 3 is due Friday. How is homework 3 going? Take a look at it tonight if you haven't, so that if you have questions, you can ask tomorrow, not Friday evening. It's a fairly simple, straightforward programming exercise. And again, you know, we want it to fit in that 2-hour window. If you find that you're going far beyond the 2-hour window, please stop and ask for help. And when you ask for help, you know, if you send me a message in Canvas, just attach your code to the Canvas, and that way I can look at it and play with it and see what's going on. And put edits inside of it and send it back to you. Generally, it's better to ask the TAs only because there's 3 of them and only 1 of me. So, you know, you're more likely to get a quicker response from them. And then the P2 is due on Monday. The P1s are all graded. And if I asked you, if I mentioned, oh man, this looks way, you know, this is a bad idea. I tended to give you insight as to how to fix that. There were only a couple of those. And so, you know, hopefully you'll have time to resolve that by Monday. If you're one of those people though, and you're really freaking out about Monday, let me know and we can talk about it. Okay, let's start with this mess. Let's see, I meant to get rid of all that. Yeah, we'll go through here. Okay, we talked about last time the is a relationship, has a relationship. The has a relationship is when one class contains another class. And really we want to talk about that with attributes, not so much objects that are created inside of methods. They both work, but primarily the important relationship there is when one class has another as an attribute. And I'll talk about that towards the end of this lecture. And then we did this zombie thing, and we started this but didn't get into it. So let me talk about this in detail, because making sure that we know what's happening. Let's see here. Forget my typos. I'm not going to fix them. Okay. If I create a object of this class, initially, what's the value of X?
0.
0, right. And if I were to do a initially, what's the value of string?
No.
And if I were to do, I have a zombie class somewhere. Initially, do I have a when I do this line of code, do I actually have a zombie created?
No.
No. What do I have? Nothing or something? Let's start there.
You would have nothing because there's nothing in there.
Okay. I've got a handle to a zombie that we haven't created yet. And what is it initially equal to?
Zero.
What's the non-numeric equivalent of 0? Null. That's why when you try to reference an object that you haven't created yet, you get something called a null pointer exception. If you ever see in your program crashes and that error message reads null pointer exception, you're trying to refer to an object that you haven't created yet. Often it's an array, often it's an object of a class that you've designed. Now, what about this? What is that? What am I trying to create here?
You're trying to create an array of zombies.
An array of zombies, right, right. And an array is an object, is that true? So what happened here when I said I have an object, right? I'm going to create an object someday, but really all I have is a handle to the object, and that handle is initially null. Here, I'm going to create an array of zombies at some point. An array is an object. We talked about that last week. So an array is an object. And have I created the array yet?
No.
No. So this is a handle to an array. And again, initially, its value is null because I haven't created the array yet. Okay, now inside main, let's do this. And let's do 50, which is, I think we can agree that's plenty of zombies. Now, what just happened in memory? First of all, do I have an array?
Yeah, you have an array now.
You have an
Can we
array.
declare the size?
Right, I have an array object. How do I know that I created a new object? The new keyword. So I've created an object, which is the array itself. So this is basically an array of 50. So there's 50 slots. Each slot is of the data type zombie, right? That's the class. So what I really have are 50 slots that are, each one is a handle to a future zombie. I have an array. Do I actually have any zombies yet?
No.
No, sir.
No. What I've got is a warehouse that was someday I'm going to fill up with zombies, or think of it maybe as a parking garage. It's 50 slots, each of which will be able to refer to or contain a zombie in the future. But right now, there's no zombies. So initially, they're each equal to null. So how do I actually get zombies? I have to do a for loop, and I have to create each one. And I'm going through this in such detail because this is an easy thing to get confused on. This is an easy thing to miss when you are doing your homeworks or your projects and you need to build an array of objects, which is a very useful thing to do. You need to build an array of objects. People will think that by declaring the array, they've actually made the objects, but they didn't. They just made the array that will eventually hold the objects. If it was an array of integers, this would already make sense to you, right? If I said int, what did I just do? Did I actually create a new object of any type?
Yes.
Do they have a value? Does each location have a value?
No.
No.
Because what does Java do? Whenever you create an integer, it automatically sets it to 0. So what happens here is, yeah, I created an array of integers and Java made them all zeros. And when I create the array of zombies, what's the non-numeric version of 0? It's null. So since I actually haven't set in the bottom line with the integers, since I haven't actually set the value at each location in the array, I am defaulted to 0. And in the zombie array, since I haven't actually created the zombies for each location, it's defaulted to null. And it's easy to get this, your program crashes and you get null pointer exception. Why did that happen? You probably didn't create an array, or you didn't create some other object. Remember, an array is an object. And so that's what's happening on this slide. I have to say, private zombies, and then inside of main, I actually make the zombies, and then I make the array, and then in the lines 14 through 18, I have a for loop that fills each location in that array with a real zombie. And conceptually, you can think of it as the zombie actually is inside the array, or you can think of it, more properly as that array is an array of handles, and each handle is now getting a memory reference to point out to where that individual zombie is. Using arrays of objects is very useful. Many of you will do it, when you're doing, again, if you're doing your platformer game and you're jumping from platform to platform, how are you going to represent those platforms in data? I would say you want to make a platform class and then make an array of platforms. And inside that class, you have to figure out what you need. And some of you are doing, zombie chase game type things, and it's the same idea. You need to have an array of characters. If you're doing the elevator simulator, you may want to have an array of elevator. You build an elevator class, and then you have an array of elevators. And so many of you will be doing this. Okay. I think that's all we need to do about the has a relationship. And now let's talk about the is a relationship. And we're going to do most of this through example. So the is a relationship is the inheritance relationship. And it's inheritance because you can hardly not use the word is a. Think about, the tree of life where they break things down by phylum and genus and whatever. The class of mammals. A whale is a mammal. A dolphin is a mammal. A dog is a mammal. Go down to canines. A dog is a canine. A wolf is a canine. A fox is a canine. Okay, so there is a relationship. And once you say that something is a mammal, don't you automatically say a lot about that animal? Warm-blooded, has hair, feeds young with milk, has a backbone, internal skeleton, et cetera, et cetera. You're giving a lot of information because under the umbrella class of mammal, all the animals underneath there inherit those traits. And that's what this is about in objects too. You inherit the trait. You want to have the inheritance relationship when you have similar classes that have different behaviors, and it's the behavioral difference that's critical. So you have the generic class, attributes and methods, the child class that inherits all those attributes and methods from the parent. And then you can add to those, you can add attributes if you want, you can add methods if you want, but most importantly, you're going to modify some of the existing methods. And some people call that overriding. The technical term is polymorphism. Okay, so as an example, and the code example I'm going to use, I have a generic shape, and then I create a circle and a square and a rectangle as children of that generic shape. And so as an exercise in design, and here that you're getting the results from last period's lecture. Let me knock those out because you guys may come to some different conclusions. All right. So let's start with generic shape. Now, when you're designing your own code, you have to make these decisions. You're the one that's going to sit down and do this. Okay, I've got a generic shape. And in this case, we're doing a generic shape. What kinds of attributes might be affiliated with a generic shape? Some kind of attribute that you think all different two-dimensional shapes might share.
Length. Also.
Length, okay. What else?
The width.
Area.
Area. What else?
Height.
Height. Okay. I'm going to put it here. Okay. Anything else?
The width.
Width, length, height. Well, it's two-dimensional, so I'm going to say length and height are the two dimensions.
Okay.
Okay. Or I should say it's flat. You can still have more than two dimensions in a two-dimensional shape.
Oh, perimeter.
Perimeter. I'm still not spelling this right. I'm just going to give up. Okay. All right. Okay. Now, what methods might you have? Besides setters and getters, what methods might you have? If you were asking questions about the shape, what kinds of questions might you ask?
What is the length or the height? Or the
Okay,
area?
so those are setters and getters of the specific attributes, right? So I'm gonna leave those be for now. We're gonna skip those. What other things might we do? How'd you get that area value?
Have a method that multiplies in length and height.
Well, is that true for a generic shape?
No, because if it's a circle, it won't work.
There you go. So, but we know that no matter what the shape is, we can calculate the area. Is that true?
Yes.
Yes. We don't know how, but we know that we want a method to do it. We don't know how to do it yet because we don't know what the shape is. So I'm going to have a calculate area method. What other things can you apply to all shapes in terms of calculations?
Calculate perimeter.
Right. What else? You can come up with stuff. Which may not be the same as the What else? Anything else? Things like that. I also have one display information. I only know because of in my examples. So you can come up with, but when you're designing your own classes, when you're doing your project, this is the exercise that you do. This is the exercise that I'm going to ask you to do for the P3 deliverable. Ask yourself, what attributes do I need? What methods do I need? And you do this for all your classes. Now for a shape, shapes are pretty passive. They're pretty boring. But you have a class that does something more sophisticated, then you work through this process of, gosh, what can this thing do? What might people ask of this shape? What might other classes ask this shape to do? If you think of your class as a service provider, what services does it provide? What does it keep track of? Okay, now let's go back here. We have an attribute for area, and we have a method called calc area. What's the rule of thumb if you have a method to calculate something? Should it be an attribute?
Probably not.
Probably not. And the same with perimeter. Now, let's get rid of the probably. I'm saying my advice is don't do it. Can you do it? Yes. It compiles and runs, blah, blah, blah. Don't do it. If you can calculate it, don't store it. Why would I say that?
Wasting space.
Pardon? No,
You're wasting space.
that's part of it. That can be part of it. Yeah, yeah. But we don't worry about memory too much anymore.
You
we used to worry about. Go ahead.
you said you can run into errors if you start.
Right, right. I calculate I set up my shape. I calculate the area. I save the area. I change the shape, but I forget to change the area attribute. Now the area is wrong. Why make life difficult for yourself? If you can calculate it, anytime you need it, you can recalculate it. Is that wasteful in terms of computer processor cycles? Absolutely. Do we care? No. We rarely care about that these days. Back in my day, you worried about memory, the size of the memory that you were using. You worried about how many computer cycles you were using. But these days, memory is cheap and chips are fast. So you should write in such a way that you are less likely to have programming errors. Write for humans, not for computers. So I've eliminated a potential problem down the road by not having attributes for the area and perimeter. What you want your attributes to be is the bare bones minimum to describe the shape or describe the class. In this case, it's a shape. And what you want in this generic version are things that are common to all shapes that you could create. Now, is length common to all shapes that you might create? And is height common to all shapes that you can create?
Yes.
Does it, what's the length and height of a circle? What if I have a weird shaped polygon?
I guess I'm thinking about like, how would you calculate the area of like a star?
Yeah, so these get tougher, right? These get tougher. Now, there's a problem here, and quite frankly, I don't know of a good solution. I kind of know of a good solution, but I don't know of a great solution. If I call it length and height, that's confusing because it's not intuitive to refer to the radius of a circle as its length or its height. Or if I have a, let's see, if I have a square, length and height is okay. Rectangle, that's okay. Triangle, that's probably okay. Rhombus, that's probably, you know, so what about, what's the, is it rhombus? It's got one side on the bottom, but the length on the top is different. And then it's got a height. So it's actually got 3 dimensions, the lower length, the upper length, and the height. So we get into a problem here. And quite frankly, I don't have a great solution for it right now, but these are the kinds of problems you run into when you're doing design. And you have 2 design choices here, neither of which are ideal in my opinion. One is you could do dimension 1, dimension 2, dimension 3, right? You could do that. Or you could do right. So now you're ready for any size. You could do that. The problem is if you, again, if you call them these generic terms like dimension 1, dimension 2, dimension 3, when I go to a rectangle, what is dimension 1 and what is dimension 2? Is one the height and one the width, or one the width and one the height? See the problem there? The good news is all shapes will have this. The bad news is we're not sure what it means in the context of a specific shape. The other way to go, which has its own problems, is to put in all the unique geometric information inside the children. But now do you see the problem? I've got different names for these attributes, which makes referring to them difficult. These are problems that you encounter. They're normal problems. By the way, there are at least 2 things, or one thing that, depending on how you look at it, that truly is going to be universal across the shapes that we haven't named yet. Where is it? So that is attributes we definitely could have. These exercises, you know, it doesn't hurt you now, you know, with your projects. Think about these classes. Think about, just rough out, okay, what classes do I need? And what attributes should they have? And what method should they have? It is not a trivial exercise. And that's why your P3 deliverable, where I'm going to ask you to give me that information, that's why I put in that it takes, you know, 8 to 12 hours. Because you can and probably should go through several iterations of this. Do you have questions? I'd rather we have questions. By the way, most systems do generic shapes, and Java does have a generic shape that they offer you. It's just an array of, they either do it as an array of dimensions or an array of points. So you can say it starts here, here's the first point, the next point, the next point, the next point, the next point, and the last point, and just assume that it's a line between the last and the first to make any kind of polygon you want.
Professor, I'm still having like a hard time wrapping my head around the attribute. So are attributes typically things that are constant, like the X location, Y location wouldn't change, and then the method would be the things to calculate what you want to modify out of your attributes?
Attributes aren't necessarily constant, but they are required to describe the object. So for instance, with a circle, how would you describe a circle? X location, Y location, and radius.
Mm-hmm.
Now that doesn't mean they're constant. I can move my circle around by changing the X location, Y location values.
Okay, I think I'm just having a hard time with, like, I understand it when it's the example, but maybe like coming up with my own attributes, if that makes sense.
That makes perfect sense. And that's why I encourage you to try it now. And when you run into that wall of, gosh, I'm not sure what to do, ask the questions now so that you can work on the P3 in a way that actually is beneficial.
Okay.
Okay, so like, you know, rough this kind of stuff out, you know, even with your own project. And if you're like, I just really don't have a clue what classes I should even be creating, that's a great first question to ask a TA or myself or a classmate. I like that question. And then once you decide on the classes and you start to think about, okay, what do I need to describe this? For example, I tried to get a team in SC300 this semester to do a game, recreate a game where you have sailing ships and navies, and the sailing ships, you know, fight each other. And the way they used to fight each other back in the days of sail is the two navies would line up in big long lines and, you know, shoot at each other. And so, you know, let's start thinking about that. And what I wanted them to have is a multi-level command structure. So if you were the commander of, you know, 20 ships, you actually only commanded 3 other people, each in command of a squadron of ships, this kind of thing. And then each of those, which would be computer players, would be in command of the individual, you know, would be talking to the commanders of the individual ships. Now, based on that simple description, can you think of any objects or classes that jump out at you?
The ships would be objects.
Objects. And I would make a generic ship, and then I would extend that because the ships come in different categories. So I'd have a generic ship and then extend that to the ships. Now that we've identified ships, what might be some attributes that you want for that ship?
Some ships could be destroyers.
It's Age of Sail.
Oh.
Yeah. So yes, and those would be the categories. Those would be the child categories. But what attributes might all those ships share?
Like speed.
Okay. Now, how does speed work back in the Age of Sail? Okay, you're going to have some kind of a speed to wind ratio or something like that, right? What else?
Gonna have like their position.
X location, Y location, and direction. Absolutely. What else? Okay, then you get into stuff like how much sail is actually up. You know, they could have no sail up and they basically sit still. They can put all their sails up and go faster, put some of their sails up, right? This kind of thing. Tonnage. Yeah, what's their draft? What's their size? And they came in standard sizes, by the way. So then you can say, oh, what's their size? And then there's stuff like how many guns do they have total? How many guns are operable because they're going to get damaged during battle? What's their crew quality? How much of their crew is remaining? How much sail can they have? How much sail have they lost due to damage? How much sail do they have left? Are their anchors up or down? Right? So you can start to just list attributes that describe the ship. And then you would have methods for increasing sail, decreasing sail, firing broadsides, firing individual cannon, turning the ship, you know, tacking the ship into the wind, which was a tricky maneuver. Up anchor, lower anchor, right? You can have methods for those things. So that would be a top level design. And it is not trivial to get it right. But now there's a whole nother thing. Remember, I brought in the command structure. Oh, so now I've got a generic commander class, and then I've got to have a way to determine this commander has these other commanders reporting to them. That one has other commanders reporting, right? So I need a structure for that too. By the way, they're not building the game. I'm terribly disappointed. So. Okay, does this make sense? In the sense of inheritance, I would have generic ship and then the child ship. In the context of how the command structure works, I would have a generic player, character, commander, whatever. And then I could extend that if I'm going to have computer non-player characters, basically, I would extend that. So I might have captains of ships who are really bad at their job. That could be an extension of the generic captain class. This one's super aggressive. This one's super timid. This one is just no good at training the crew. Different behaviors may result from that. And then I would have to figure out what attributes and methods I need for that, which we don't need to do here. So I'm trying to give you an idea of the process and how you might use inheritance in a project. Am I doing that at all? Is this helpful at all?
Yes.
That was a lone yes. Thank you for your thank you for your vote.
Now you got me thinking on what to do for my
Good. Yeah, and you need to be doing that now. Good. Okay. So here's what I've created. I've created this generic shape, circle shape, square shape, rectangle shape, and then I have a shape controller. So let's go through this fairly quickly. This thing has basically what we decided on: X location, Y location. I gave it a name just to give it a new, another attribute, but there's no real reason to do that. And then I made the decision where I kept the dimensionality out. And then I say circle shape, and notice what we say: circle shape extends generic shape. So it is a generic shape. It's the is a relationship. And I gave it an additional attribute for radius. Both ways of doing this have issues, right? And so this way does have issues. And then there's some different constructors here. And then if we look in generic shape, I said display shape info. And all I do is I say, I don't know how to display the shape info because I don't know what shape I have, so I just print this out. This is a generic shape. And you shouldn't be seeing this, is what I printed out. It is legitimate to print things out that say this should not happen. That's a legitimate thing to print out. Okay. So basically what I'm doing in the generic shape is I have all the methods there, but I put in dummy definitions for them because I don't have a correct way to present area. I don't have a correct way to present perimeter. So all I do is I print out messages that say basically this hasn't been defined yet. And then some of these methods have return values, and so I have to give a return value. So I just go ahead and give a bogus return value and print out the method that says, this is not defined yet. This method isn't defined yet. And again, this is how I recommend that you actually construct your own projects. You build all these things with methods that don't do anything, but what you're doing, you can actually run all your code. And you're making sure that the skeleton is correct, that your classes talk to each other, that you're actually building the objects that you think you're building and that you're able to work with them. Nothing happens correctly, but you can build out like I say, the skeleton of your project. And then you start working on one method at a time, like we did last week. Okay, so then I went ahead and I built, circle shape extends generic shape, square shape extends generic shape, rectangle shape, okay, on and on. And inside of circle shape, if you'll see, I put in a whole different set of code for display shape info. In the display shape info on the generic shape, it just says, this hasn't been defined yet. You shouldn't be seeing this. And here I actually can produce the actual shape info information, so I can actually do it. I can actually calculate the radius and return the radius. Right, and the same with the perimeter and center of mass, which for the circle, of course, is just the center of the circle. So here's what happens. Let's say I call calculate area. I call calculate area. I create an object of circle shape, and I call calculate area. What does the Java virtual machine do? It goes to circle shape and it says, do you have a calculate area method defined here? Which it does for lines 42 through 44. That's the one the Java virtual machine will use. But what if it can't find it? What if the Java virtual machine goes here and says, I need a calculate area method, and it's not defined here? For example, under rectangle shape, you'll see that I didn't change any of the methods. So if I built a rectangle shape and then I called calculate area, what's the Java virtual machine going to do? It's going to go here, look for calculate area, not find it. Now what do you think it does? It doesn't crash.
Just go back to generic shape and look for
Exactly.
it there.
It says, oh, I see that you extend generic shape. I'm going to go to generic shape and look for a calculate area method there. And here it is. I'm going to do that. It's always looking at the most local definition of the method. And this is why I'm saying, my comments to P1, people were giving me what they thought was inheritance, and I was arguing against it in a fair number of cases. And this is what I'm saying. How do you know you have inheritance? Or how do you know you have a really good case to make that inheritance was necessary? If you're changing the methods. Ideally, all the attributes are inherited with no change, and then the methods are inherited, and some of them will change. Maybe you have 5 methods, but I'm not talking about the setters and the getters. Those are always good. Maybe you have 5 methods, and so up in your generic class, and then when you extend that to the child class, maybe you only have to change 2 of those methods. That's okay. That's normal. A lot of the methods you may be able to keep the same, but then some of the methods are showing you the fact that you had to change the methods is showing that you're having behavioral differences, which is generally the best reason to have inheritance. Now, generic shape has X location, Y location, and string. So how many attributes do we have here? Are those attributes, first of all?
Yes.
Yes, because they are not declared inside any method. So they are attributes, which means all the methods have access to them. And down here in rectangle shape, I don't declare any attributes. How many attributes does rectangle shape have?
None.
3. 3 is the correct answer. How did it get 3 attributes? It inherited them from generic shape. So remember, that's the whole point, inheritance. So what's happening here is, remember the different reasons why object-oriented programming was supposed to be a good idea. The first was encapsulation, data encapsulation, and as we'll talk about later, actually functional encapsulation, and that was hugely successful. The next one was code reuse, which was somewhat successful. This is where you're really getting code reuse. The rectangle shape is a fully functional, correct, has attributes, has methods class, and look at all the typing I did, nothing. Because I inherited from generic shape. And the other thing is program understanding, which is again helpful here because I call this in the top level class X location, Y location, or X LOC, Y LOC. And if I were to redeclare these down here, if I wanted to say, okay, I need a rectangle shape and I'm not even going to extend generic shape, I'm just going to make a rectangle and I might call it X location, Y location instead of X LOC, Y LOC. Now that's different names for different things in different classes, and that's confusing. And it can also lead potentially to problems, which by the way is why I said there was no great answer to the dimensionality problem. I'm calling the dimension a radius in the circle. I'm calling the dimension a side length in a square. And I'm introducing a problem into my code because they have different names for the single dimension that you need for these guys. Okay, so I have this generic thing. And what's happening when you actually run the code is the Java virtual machine first looks in the class for the method that you asked for. And then if it doesn't find it, it will go to the parent and look for that method. And this can go up, it keeps going up the chain. we'll see with, we'll see when we get into the graphics stuff, the Java FX stuff, how that plays out. That you get a simple thing on your screen, but it's a child of a child of a child of, and it has all kinds of functionality that it inherited. Okay, I'm gonna, something else with that. One thing to be aware of, and this is tricky. Private means private. What does it mean when I call these X location, X LOC, Y LOC, and object name? I declared those all as private, right? They're attributes, and I tell you, and I believe this, all your attributes should be private. So who has access to those attributes?
Only the methods. The
Only
steps.
the, right, only the methods in this class. Only generic shape, the class generic shape is the only one that has access to those attributes. Now, this is a parent and rectangle shape is a child. And I said rectangle shape actually has 3 attributes: X location, Y location, X LOC, Y LOC, and shape name, or whatever I called it. Okay, so how many attributes does it have? 3. Can it access those attributes directly? What does your intuition tell you?
No.
I mean, that's the correct answer. Private means private. Only generic shape can access those things. And even though it's a parent, it's kind of a stingy parent. It gave those attributes to rectangle shape, but rectangle shape cannot access them directly. So how does rectangle shape have to access XLOC, YLOC, and the shape name? It has to use the setters and getters in the generic shape class. And that is not, to my mind, intuitive, but it's good to know so that you don't spend 3 hours driving yourself crazy. Why can't I get access to the location of my rectangle? So if you look under circle shape, when I print out my X and Y positions, I don't just print out XLOC, YLOC, because circle shape, which is a child of generic shape, doesn't have direct access to those attributes. It actually had to use the getter for those attributes. It's a little annoying. It's, to my mind, not intuitive, but it's not that big a deal in the long run. And quite frankly, it does. When we talk about encapsulation, it does maintain encapsulation. So, oh, I gotta let you go. I'm gonna keep. Yeah, I'm gonna let you go, and I'm gonna finish up just look at the difference of shape controller and how lousy it is because I have no attributes, and better shape controller, which actually built attributes of this class. And I talk about this in the pre-recorded lectures, so I'm not going to repeat it here because but be aware of that. And then also, hopefully I got you thinking about, gosh, I really have to think about how to create my classes and my objects inside of my project. Just start drafting that stuff up in your head, ask questions. If you come up with a design, hey, I think I need these classes, ask the TAs, ask me. I've got a generic discussion in the Canvas page. That's what that's for, is you can just post your ideas and ask your classmates if you think it's a good idea. And I know there's a lot of Discord server help going on too. Okay, quick questions before we go. I'm overtime. For the Agile Scrum sheet, what dates were we? Oh, put in the dates for this semester. So whenever P3 is due, that's your start date. And then you can look at the schedule and this, and I'm sorry, P3 is your start date, and then just linearly go down to the end of the semester, May 3rd or something like that. Okay. Okay. Thanks, guys.
Have a nice day.
You too.